construction and working of DC machine. This is your DC machine. This is stator, stationary part of the machine. Rotor is a rotating part. Okay, I'll be cut into two half. I'll take vertical cross section. Okay, for drawing this diagram quite difficult, right? I'll redraw once again for your understanding. Easy way. We'll draw DC machine construction diagram. And you draw one inner circle. Okay, and draw vertical lines here 2, because this one is a 4-pole machine. Here 2. Okay, and join here to here, and just you draw half moon shape here. Okay, so this is your yoke outer cover. Okay, and this one is pole core, and this one is your pole shoe. Okay, field winding I'll place over here. Field winding. Okay, this is your electromagnet. Like this I'll connect plus minus for excitation purpose, just excitation purpose. This one is a field winding. Next, rotor slots. So draw 2 circles. Okay, and this one is shaft. So I'll be placing conductor over here, conductor, and this one is a commutator. And here there is a brushes. This is your output. Okay, armature slots, armature conductor, commutator, brushes. This is your base. This is your shaft. This is your diagram. Like this we have to draw in your examination. So stator part, stationary part of the machine. Till here stator, rest of the part is inside there is a rotor. Stator part we are having yoke and pole core and pole shoe and field winding. Okay, this is your stator part. And rotor part we have a rotating part, that is one armature slots, armature conductor, commutator, and here brushes. Brushes is not a rotating part. This one is it is placed in the rotor. Okay, and shaft. Okay, we'll compare with this diagram and then these two diagrams. So yoke, this part, outer cover of the machine, here there is a yoke. Okay, and then pole core, here pole core is present. Pole shoe, this one, and pole shoe inside will be there, not visible. And then field winding, this field winding is here. It is surrounded with a pole core. Okay, this is field winding. Okay, next there is a rotor part. Rotor part, armature slots. These are slots is present over here. These are the slots. And armature conductor over here. Right. So it is placed in the armature slot. Next there is a commutator. Commutator is present over here. This is a commutator. Okay. This is a commutator. Next brushes. Brushes is here. So brushes is here. Brushes will be contact with commutator. But these two are stationary. But we are considering as a rotor part. And next there is a shaft. A shaft is this one. And bearing is there for smooth operation. Okay. Parts of the machine in detail. First one is stator, stationary part of the machine. In that we have yoke, pole core, pole shoe, and then field winding. Right. Yoke is a outer cover of the machine and frame for the machine, and also it avoids entering of dust particles, moisture contents inside the machine, and also provides mechanical support to the pole core and pole shoe. I mean, it holds the pole core and pole shoe by using bolt and nut over here. And also it provides low reluctance path for the machine. It is made up of cast iron or silicon steel. Okay. So next there is a pole core. Pole core is for to holding the field winding. Okay. And then pole shoe to enlarge the core area and enlarge the flux like this. Okay. Like this. Okay. And it provides a low reluctance path. Next there is a field winding. Field winding is for to produce magnetic field. Constant magnetic field is needed. See here, don't confuse. This is not an output. This is just for excitation purpose. We are having plus and minus. If you want, you can remove this plus and minus. Don't confuse. Just to place field winding. Next, there is a rotor. Rotor is a rotating part of the machine. This part, okay, rotor. And first one is rotor slots. This slots. This slots is for to holding the armature conductor. Okay, this armature conductor. So these are the rotor slots. To hold armature conductor, we have slots. Slots is made up of cast iron or silicon steel. Next is the rotor armature conductor. Rotor armature conductor, when conductor cuts the magnetic field, EF is induced. Work has to be done, right? These are the armature conductor. Here there is a magnetic field is present, okay? Magnetic field is present. Next, commutator. Commutator collecting the current from the armature conductor. And commutator converts AC to DC because when conductor cuts the magnetic field in the armature conductor, that is AC. Because we want DC output, that's why commutator converts AC to DC. If it is motor, it converts DC to AC. Okay, and it is made up of copper. And next is the brushes. Brushes collecting the current from the commutator. Brushes made up of carbon or graphite. Okay. Next there is a shaft to holding the total overall armature conductor. Bearings for reliable operation. Once again, stator is the stationary part of the machine. Yoke is there. Yoke is the outer cover of the machine, and also it avoids entering of dust particles, moisture content inside the machine, and also it holds our mechanical support to the pole core and then pole shoe. And next there is a pole core. Pole core is for to holding the field winding. Okay. And next there is a pole shoe. Pole shoe for enlarging the core area, enlarging the flux, and providing the low reluctance path. And next there is a field winding. Field winding is for to produce magnetic field. Because magnetic field is necessary to induce EMF, right? And next there is a rotor part. This one, okay? And here rotor slots. Rotor slots is for to holding the rotor armature conductor. Rotor armature conductor is for whenever the conductor cuts the magnetic field, EMF is induced, right? So work has to be done in this armature conductor. Next there is a commutator. Commutator which collect the current from the armature conductor. See here, collecting, and also which converts AC to DC. For generator, DC to AC for DC motor. Next, there is a brushes. Brushes collecting the current from the commutator. Collecting the current from the commutator for external circuit. It is made up of graphite or carbon. Next, there is a shaft to holding the overall rotor. And next, there is a bearings for smooth operation as well as reliable operation. That's all. Okay. You can draw any one diagram. 2-pole machine. This one is a 4-pole machine. Once again, revise construction of DC generator. These are the stationary part of the machine, stator. Okay. Yoke is the outer cover of the machine, and also it avoids the entering of dust particles, moisture contents inside the machine, and also mechanical support to the pole core and then pole shoe. Next, there is a pole core. Pole core is for to holding the field winding. Next, there is a pole shoe. Pole shoe is for enlarging the core area. The rotor core area, and also enlarging the flux like this. Okay, like this. And next there is a field winding. Field winding is for to produce a magnetic field. Field winding is made up of copper. And then the pole core, yoke, pole shoe made up of cast iron or silicon steel. Keep it in your mind. Next is a rotor. Rotor is a rotating part of the machine. So here there is a rotor slots. So rotor slots is for to holding the rotor armature conductor. Here there is a air holes for cooling purpose. Okay, there is a number of stampings to eliminate lasers. Keep it in your mind. And next there is a armature winding. Armature winding in sense here we place armature winding, armature conductor. That is called as armature winding. When conductor cuts the magnetic field, EF is induced. Work has to be done, right? So that purpose we are having armature conductor over here. So here two types of windings. One is lap winding and another one is wave winding. We'll see lap winding, wave winding in brief. I'll make another video in detail. So see here there is a lap present here to here. Number of parallel paths is equal to number of poles. Here only 2 parallel paths. See here A is equal to 2. Only 2. It is connected here. Commutator segment here and here. A is equal to 2. Okay. Next there is a commutator. Commutator which collect the current from the armature conductor, and also it converts AC to DC, acts as a rectifier for DC generator. If it is a DC motor, acts as a inverter, DC to AC, right? See here, DC output only. And there is a brushes, collect the current from the commutator, right? And it is contact with always a commutator. Next, there is a bearings for smooth operation, reliable operation. Final touch, yoke, pole core, pole shoe, and this one is a armature slots, commutator, and this is shaft, and here there is a brushes. Here there is a armature conductor, right? So one by one, yoke is the outer cover of the machine, and also it avoids entering of dust particles, moisture contents inside the machine, and also mechanical support to the pole core. Next there is a pole core, it holds the field winding. Next there is a pole shoe, enlarge the core area and enlarge the flux, right? And next there is a armature slots holding the armature conductor. Armature conductor, when conductor cuts the magnetic field, EMF is induced, work has to be done. And commutator collect the current from the armature conductor and also converts AC to DC. Next there is a brushes. Brushes collect the current from the commutator. Okay, and this is the external circuit. Next there is a shaft holding the overall rotor. See, yoke, pole core, pole shoe made up of silicon steel or cast iron, and this winding, field winding, commutator made up of copper, and this brushes made up of carbon,